We are going to continue what we have left in the first stream. In the first stream, we covered the basics of C programming language, and we try to understand what are the different programming constructs in C programming, like if block, else block, switch case statements. How can we take an input from the standard input? How can we print to standard output? So these are some of the programs we wrote. We know how to call a function, and here we write some if-else blocks, how if-else works, how a while loop works. Apart from that, we also worked on how to increment an integer and how to format a print using printf. For example, using these delimiters percentage, not delimiters, formatters percentage, %d. And we also learn how can we take input from the user. But today, these are the basic concepts of the programming language, C programming language. But today we will try to cover the chapter 2. And in chapter 2, it is the most difficult aspect of a C programming language, memory and pointers. So this is the these are the things we will be covering. The chapter name is memory and pointers, and we will try to understand it and we'll continue. Okay, so let's get started. So they are saying that a C programming language gives us a lot more control over how we use program and the computer's memory. In this chapter, we will strip the covers and see exactly what happens when we read and write variables. We will learn how arrays work, how to avoid some nasty memory, SNAFUS, I don't know what that is. And most of all, we will see how mastering pointers and memory addressing is the key to become a kick-ass C programmer. So that is 100% true that we have to master pointers and memory addressing if we want to be a good C programmer. Not only C programmer, if we want to be a good programmer at all, because today programming languages like Golang and Rust also include this pointers concept. So if we really want to be a kick-ass programmer, we have to understand this memory and pointers, and C is the best programming language to understand that. Pointers are one of the most fundamental thing to understand in C programming. So what is a pointer? A pointer is just the address of a piece of data in memory. So if you have a piece of data, that means if we have a variable, for example, in the earlier chapter, we have created a lot of variables. For example, card count, this is a variable. And where this variable is getting stored, that piece of memory is called a pointer. A pointer is just the address of a piece of data in memory. Now, what are the uses of pointer? Instead of passing around a whole copy of data, we can just pass a pointer. So that will save some sort of information. Copying the data, for example, a data is of, let's assume 64 bytes. Rather than directly copying the whole of the data and passing it around, we pass the address. So sometimes you want to, you might want two pieces of code to work on the same piece of data rather than a separate copy. Then we can use pointers. Pointers help you do both these things, avoid copies and share data. But if pointers are just addresses, why some people find them confusing? Because they are a form of indirection. If you're not careful, you can quickly get lost chasing pointers to memory. The trick to learning how to use C pointers is to go slowly. Okay, so we will try to go slowly in this chapter. So they are clearly mentioned, don't try to rush this chapter. Pointers are simple idea, but you need to take your time and understand everything. Take frequent breaks, drink plenty of water, and if you get really stuck, take a nice long bath. This is their sort of what they are trying to convey. So let's have a look at the book. So digging into memory. So they have shown us a, let me zoom it out. They have shown us a layout of a memory. So this is a memory, and the code, basically whatever we write the code, where does it lies? It lies at the bottom. So in the memory, it lies at the bottom. Above it there is a space for the memory where constant resides, and above that there is a space for memory where globals reside, and above it there is heap, and above it there is stack. So it is a layout. So if we try to understand, first constant, then first, my mistake, first code, then constant, then global, then heap, and then stack. Now we will try to understand what are these terms, what is heap, what is stack. To understand what pointers are, we will need to dig into memory of the computer. Every time you declare a variable, the computer creates space for it somewhere in the memory. Exactly, because whatever at the runtime, whenever a variable is declared, so computer stores it somewhere in the memory. If you declare a variable inside a function, the computer will store it in a section of memory called the stack. So we have to highlight it. The very important point. Whenever a function is created and whatever the variables are created inside a function, those variables are stored in a section called stack. If a variable is declared outside any function, it will be stored in the global sections of the memory. So we have to remember that also. That if we are, for example, the example is given here, but still we will see in our code also. So if we try to go to the previous chapter, so here we are creating a variable max, and max is inside the main function. So it will get stored on the stack. But what if we are trying to create some global variable, let's say int z equal to 3. This will get stored in the global section of the mem3. So this is what we have to understand. The same thing is mentioned. Variable variable y will live in the global section, and they have also assumed that the memory address will be this. But x, which is defined inside a function, will reside inside the stack. And okay, so let's continue. And each thread has its own stack, and those concepts I think we will cover in the later chapters. The computer might allocate say memory location 410000 in the stack of for the variable x. If you assign the number 4 to the variable, the computer will store 4 at the location. So this location, this memory, what is the value? What will be the value that gets stored to it? The value which we are going to assign to it, and that is 4. If you want to find out the memory address of the variable, we can use the AND operator. This AND operator. X is stored at %p, and p is the formatter which we use, like %d for integer, %s for string or array of characters. Similarly, %p is the formatter to print the address. Let's give it a try quickly. Okay, so we will create a variable x equal to 400, and we will print x is stored at percent. Oh, sorry, I named my file Go. So we create a variable x equal to 4, then printf x is stored at percent as we at %p, and we will pass the address of that. So let's try to run this. So as we see, gcc name of the file memory.c-o mem, then we execute the mem. So as I have been doing this mistake continuously in the previous stream also. So we will check when we execute, so it prints the address. And to be honest, if I do remember that this is not the exact address, it is sort of a virtual address. So we will never be able to see the exact memory address. So it is a sort of memory address, virtual address which gets displayed, but it is quite understandable that this is the address where the variable x is getting stored in the stack. And every time we run the program, we will see that this address will get updated, because obviously memory, whenever a program gets executed, new process is getting created, and each time a process gets created, new memory space will be allocated, and as soon as the process gets killed, that memory will get filled. Okay, so let's continue. The address of the variable tells where to find the variable in memory. That's why an address is also called a pointer, because it points to the variable in memory. So a variable declared inside a function is usually stored in stack. We already read this. Now they have given some analogy. Let's sail with pointers. Imagine you are writing a game in which players have to navigate their way around the Bermuda rectangle, not triangle, rectangle. This is the interesting part about this Atlas book, because they make beautiful analogies. They try to engage the reader a lot. The game will need to keep control of a lot of things like scores and lives and the current location of the players. You won't want to write the game as long as one large piece of code. Instead, you create a lot of smaller functions that will each do something useful in the game, and that is so obvious. Whenever we write a code, we try to write small functions. What does any of this have to do with pointers? Let's begin coding without worrying about pointers at all. Okay, so a major part of the game is to be navigating your ship around the Bermuda rectangle. So let's deep dive into what code we will need to do in one of the navigation functions. So they are going to talk about the navigation function. The game will track the location of players using latitude and longitude. The latitude is how far north or south the player is, and the longitude is her or his position east or west. If a player wants to go to travel southeast, that means her latitude will go down and her longitude will go up. Okay, so let's try to understand. If he or she wants to go southeast, latitude will go down and longitude will go up. Okay, go southeast, so latitude will decrease and longitude will increase. Okay, so we will create a function go southeast, and as they have explained. So let's try to write the code. Go to the corner. So okay, so lat is, let's assume, whatever, 53, and long is 33. Let's assume go. So we will create a go south east, and in that southeast we will pass a latitude and we'll pass also longitude. And then what we will do, printf lat is now %d comma long is now %d comma lat. What we will do here is we will also print lat is now %d comma long is now %d lat comma long. And now we will create a function which will return nothing. It will return nothing. So we will create a void function and name it go south east, and it will take an int lat and int long. Okay. And inside that, what we have to do, we have to increase lat by, so what it was mentioned, decrease lat by 1 and increase lon by 1. Okay, so this was our whole code. And why is it is of this type void intent. We are also passing it. What we are going to print here, puts going south east. And what is implicit declaration of function. So now what we are going to do is we are going to create a hash include strlib dot h. Fine. Okay. So now it is fine. So there are no lint errors right now. So what we are going to do is first we are going to create an integer latitude, integer long 33. Then we will print the current latitude where it is, latitude and longitude. Then we will go southeast, and we are printing here also that in order to understand that it is going southeast. Okay, then we will go southeast, that is decrease latitude by 1, increase longitude by 1, and then we will print. So if we run this program, so first latitude is 53, longitude is 33, going southeast. Then latitude is now 53, longitude is still 33. So they are saying that the value of the latitude and longitude does not change. Why? Why this happened? Because we all know that passing parameters in C programming language is passed by value. So it is not, so whenever we pass a variable latitude and longitude, two separate variables are created in memory at a totally different address. So how can we see that? Okay, so what we can do is we can use address of lat is, we will only try to understand with the lat. Okay, and then we will check here the address of lat also. Okay, so if we again build the program and execute it. Okay, my mistake. Okay, we will do here. Now let's build it. So the address of latitude here was, if you can see, 63870, and here it is 63DA4C. So when we decremented the latitude, it was being decremented at a variable which was stored at this address. And the value which we are printing here is a variable of latitude which was stored at this address, which was not being modified, which was not even being touched. That's why whenever we pass a value, whenever we pass a variable directly, it gets copied in the memory and a separate variable is getting created. And whatever change we are going to make in that method is going to make change in that specific copy. So if we again go to the book, they will also show the same things. So what they are trying to make us understand is C sends argument as values. The code breaks because of the way C calls function. So let's try to understand. Initially, the main function has a local variable called longitude that has value 32 exactly. When the computer calls go southeast function, it copies the value of the longitude variable to the lon argument. This is just an assignment from longitude variable to the lon variable. When you call a function, you don't send the variable as an argument, just its value. So we don't send the actual, we will highlight this. Whenever we call a function, we don't send the variable as an argument. We just send its value, and that value is getting copied into a totally new variable. When the go southeast function changes the value of lon, the function is just changing its local copy. That means when the computer returns to the main, the longitude variable still has its original value of 32. So these are two totally different variables at different memory. So whenever we change in function go southeast, it does not impact the function, the variable inside the main function. Now, what is the solution? It is easy if you use pointers. Let's see. Try passing a pointer to the variable. So first we will write down the code and then we will try to understand what they are saying. Okay. So now, rather than passing the latitude, we will pass the address. Okay. And here, I don't remember the syntax to be honest, but let me give it a try. Pointer to an integer. So there is no error here, right? So what we will do here is value at lat is equal to value at lat minus 1, and similarly value at value at minus 1. So now if we are going to put this code, so now you can see lat initially was 53, longitude was 33. Now lat is 52. So it is lat is 52, it is decremented by 1 and longitude is increased by 1. And if you see the address now also the address is different. Lat is address of lat is different, but maybe let's see why they will give you the explanation. Address is totally different, but I think the impact is there. So let's try to understand. Instead of passing the value of the latitude and longitude variables, what happens if you pass their address? If the longitude variable lives in a stack memory at location for what we printed here is that was the mistake. Address of latitude. So we don't have to print the address of latitude. We just have to print the latitude. Yes. No, that was the mistake because I was printing the. Now you can see the memory of both the latitude variables are same. Okay. So the latitude is stored at here. It is stored at this memory, and here also it is stored at this memory. That is why we are clearly able to change the value of the variable. Now let's see what it is trying to say. What happens if you pass the location number 41000000 as a parameter go southeast function? If the go southeast function is told that latitude value lives at this, then it will only be able to find the current latitude value, but it will be able to change the contents of the original latitude variable. And the function needs to do is read up and update the contents of the memory location. So what we are doing here in this code, we are finding the value which is being stored at this memory location. So we are passing the memory location from here and we are trying to find out what variable value by using this format, what actual variable value is stored there, and we are formatting that and storing back in the same memory. So if you want to refer to the memory, you have to use AND operator. If you want to refer to the value which is being stored at that memory, you have to refer to the star operator. Okay, so it is clear. You want to refer to the memory, for example, let's assume there is a variable int y equal to 3. If you want to refer to the memory of y, you have to use AND operator. And if you want to now pointer mem_y, so you can refer to the address of y. And if you want to the value of y, you can do it with the help of, so is it the correct way? Mem_y unused variable. So they are trying to say mem_y is unused variable. This can be more. Okay, so we understand. And if we are going to printf address of y is %p, what is the address of y? It is memy, and printf value of y is %d val y. So let's again run this code. What mistake here, what I have done. So we can see here address of y is this, and value of y is 3. Value of y is 3, and address is this. So whenever we want to get the address, we can use ampersand, and whenever we want to read the value from the address, we will use star asterisk, which is also called asterisk. Okay. And we also have to define, whenever we are trying to store some address, we also want to define what is the type of the address. So how do we define it? And we define it like this. So there could be also a float variable. For example, let's assume we have a float variable m equal to, and the value is 3.3. Let's assume. Okay. But if we want to store the float variable's memory, float pointed to mem of mem equal to, this is the correct. So depending upon what which variables memory you are, which variables address you are going to store, you have to define your memory address. If it's float, you will write float star variable name. If it's int, you will write int star variable name. So we can now let's go back into the pointers. Make it easy to share memory. This is one of the main reasons for using pointers, to let functions share memory. So the function to share memory. The data created by one function can be modified by another. So as long as it knows where to find it in memory, and this is sometimes very risky. Maybe later on we will try to understand it. Now that you know the theory of using pointers to fix goes of these functions, it's time to look at the details of how we do it, and we have already done it. So, but let's try to understand how they are and how they are explaining things. There are three things you need to know in order to use pointers to read and write data. Get the address of a variable. You have already seen that you can find where a variable is stored in the memory using the AND operator. Because once you have got the address of a variable, you may want to store it somewhere. To do that, you will need a pointer variable. So there are two. Uh, one is how to get the address using AND operator, and the variable where we will store that value, it is called pointer variable. A pointer variable is just a variable that stores a memory address, nothing else. When you declare a pointer variable, you need to say what kind of data is stored at the address it will point to exactly. So if you are so it is a better explanation than I was explaining things. So they are saying, when you declare a pointer variable, whenever we declare a pointer variable, we have to say what kind of data is stored at the address it will point to. So the type of data that will be stored at that specific address is int. The type of data that will be stored at that address could be float. So we have to tell that. So that's why we have to write int. This is a pointer variable for an address. Pointer variable for an address that stores an int. Clear? So how now, what if we have an address? Now we want to read the contents of the address. When you have memory address, you want to read the data that's stored there. You do that with the star operator. So now we want to read the value. What is value? What is the specific value that is stored at that? We use to star star operator, and the star operator is set to dereference a pointer. Dereference means gets the value from that specific address and read it. Change the contents of an address. If you have a pointer variable and you want to change the data at the address where the variable is pointing to, you can just use the star operator again on the left side of an assignment, and what we did with the longitude and latitude. So while updating the longitude and the latitude, we use the star operator. So dereference the latitude memory and update the value at that specific memory to the current value. What was it that at memory? -1. Same with the longitude. So update the value at that memory, value at that memory address, value at that memory address +1. So the current value at that memory address will be the previous value +1. So now they will, so I didn't, let me first highlight it. And now they will try to write the ghost function, and whatever we have done in our code, they would also do that. So starlat equal to starlat +1, starlon equal to starlon +1. Oh, so easy, easy. We can skip it. Variables are allocated storage in memory. Local variable lives in stack. Global variables lives in global section. Pointers are just variables that store the memory addresses. Pointers are variable that store the memory address. We have to remember it. And the AND operator finds the address of a variable. Star operator can read the contents of a memory address. Star operator can also set the contents of the memory address. Though these are very, very important bullet points. Okay, let's move further. So let's try to answer some of these questions. There are no dumb questions. Are pointers actual address location, or they are some kind of reference? They are numerical addresses in processor's memory. Okay, what does that mean? Each process is given a simplified version of memory. It look like a single log sequence of bytes. So it is a sequence memory, but simplified. To be honest, each process is given a simplified version of memory to make it look like a single long sequence of bytes. And memory is not like that. It is more complicated in reality. So that's what I was saying earlier, that it is sort of a virtual memory that is being assigned to a specific process in order to understand. It is more complicated in that, but the details are hidden from the process, so that the operating system can move the process around in memory or unload it and reload it somewhere else. Is memory not just a long list of bytes? The computer will probably structure its physical memory in a more complex way. The machine will typically group memory and addresses into a separate banks of memory chips. Do I know to understand this? For most programmer, you don't need to worry about the details of how the machine arranges its memory. Why do I have to print pointers using the %p format string? So these are called format string. %d, %f, %p. You don't have to use %p string on most modern machines. You can use %li, although the compiler may give you a format if you do. What does %p format display for? It refers to the memory address. A simple format string. If reading the contents of a memory location is called dereferencing, does that mean the pointer should also be called references? Yes, some callers call pointer references because they refer to a memory location. C++, we don't care about that. No, oh, thank God, we are not going to look at C++ because I hate C++. Okay, so let's move on. How do you pass a string to a function? Okay, so I think that's enough for today. We have covered a lot of things today, and this is a very important part, and we will try to cover it tomorrow and try to understand how we will do it. And this is page number the page number 3. Okay, this is page number 53. Okay, so we'll continue from the page number 53 tomorrow. You can go through again through this video and try to understand what we have covered today, and just practice it. So see you tomorrow. Thank you.